At exactly 30 meters, or 98 feet under the ocean's surface, marine sonar arrays mapped an anomaly that shouldn't exist. It is a massive stone structure stretching over 150 meters, or 492 feet, across the seafloor, displaying highly precise, rigid 90-degree geometric intersections. You would expect a prehistoric formation found this deep to be a relatively recent geological occurrence, but when oceanographers ran deep-sea core samples through specialized radiocarbon systems, the empirical data revealed a profound chronological paradox. The results explicitly confirmed that this entire structural foundation was swallowed by rising sea levels exactly 12,000 years ago. But the detail most people miss is that according to official paleoclimate sea level models, this precise subsurface shelf was completely dry, exposed land during the terminal phase of the last ice age. This means we are looking at an immense structural layout that was permanently sealed away by the ocean before the first stone cities were ever built on dry land. Is it possible that nature alone can fracture bedrock into such flawless architectural patterns, or are we staring at the physical remains of an undocumented pre-glacial human intervention? This structure stands as a stark contradiction to everything we know about early human history. To find out why, we must drop beneath the surface to examine the raw oceanographic data firsthand. When you dive down to the site's actual coordinates, the environment itself becomes the central puzzle. You would normally expect an ancient underwater reef to be chaotic, jagged, and heavily asymmetrical due to millions of years of random marine biology growth. But this shelf displays an eerie, mathematically uniform layout. The main platform sits perfectly level on the seabed at a depth spanning 30 to 45 meters, or 98 to 147 feet. What puzzles marine surveyors is that these massive stone terraces feature less than 1% grade variance across their entire horizontal span. This is a level of flatness that is incredibly rare in marine topography. The massive scale suggests an immense natural force, but the sheer geometric precision points to something else entirely. This brings us directly to the empirical material data collected from the stone itself. The physical evidence locked inside the stone composition provides the first hard data points. Petrographic analysis of core samples extracted from the platform walls confirms that the material is native, high-density sedimentary sandstone. You would expect an artificially built monument to be constructed from imported stone transported from distant quarries, but these blocks are chemically identical to the local continental shelf bedrock. Visual surveys conducted by deep-sea remote-operated vehicles show horizontal and vertical planes intersecting at near-perfect right angles. This level of alignment immediately sparked intense scientific debate. Initial seismic scans hinted at potential hollow internal chambers beneath the main terrace, a claim that researchers are currently working to verify. Here's the catch. Despite the structural appearance of deliberate masonry blocks stacked on top of one another, there is an absolute absence of mortar, adhesive, or artificial binding material holding the site together. The colossal stone layers rely entirely on gravitational pressure and incredibly tight interlocking placement to maintain their structural integrity against intense underwater currents. That sounds simple until you see what happens next in the structural data. When oceanographers mapped the outer perimeter of the shelf, they discovered that the stone blocks do not just sit loosely on the seabed, they are structurally continuous with the deep foundation reef itself. This structural continuity means the entire formation is carved or fractured directly out of the Earth's crust, rather than being assembled piece by piece. Without human tool marks, the massive scale suggests an immense natural force, but the sheer geometric consistency continues to defy standard geological explanations. To understand if nature alone could achieve this, we must examine the absolute limits of the historical timeline. Isolating established empirical facts from active scientific unknowns is critical to decoding this mystery. The primary confirmed data point is the timeline of inundation. Marine radiocarbon dating of organic sediment layers directly overlying the stone platform proves that the site has been continuously submerged since the early Holocene transition, precisely 12,000 years ago. You would expect a site of this immense scale to leave a heavy footprint of human occupation if it were an ancient outpost, but oceanographic core sampling has revealed a massive paradox. Analysis of local sediment layers shows a total absence of micro-charcoal, knapped stone tools, or organic refuse. The site is entirely sterile. This is where the evidence starts to shift. While mainstream archaeology uses this absolute lack of cultural debris to argue against human origin, marine geologists face a different gap. There is currently no recorded modern parallel where underwater currents and thermal fracturing have produced multi-tiered, perfectly level steps over a span of 150 meters without leaving chaotic, jagged debris fields nearby. The vertical walls remain an active gap in modern Earth sciences. The structure sits in a region known for high seismic activity, leading some researchers to hypothesize that ancient earthquakes could have shattered the sandstone into clean, parallel segments. However, the inability of current tectonic models to fully account for perfectly flat, multi-tiered terraces means a unified scientific consensus is still completely unconfirmed. We are left with a site that is archaeologically empty but geologically impossible to ignore. This profound data gap has divided the scientific community into two fiercely competing explanations. When we weight the available oceanographic data, two primary hypotheses emerge to explain this underwater anomaly. The first, and most scientifically likely explanation, is a phenomenon known as orthogonal tectonic jointing. You would expect natural rock fractures to be random and uneven, but sedimentary sandstone under intense regional stress can split along intersecting fault lines, creating near-flawless blocks that mimic human engineering. The second, highly disputed hypothesis suggests that the site was an exposed coastal cliffside before the post-glacial sea level rise. Proponents of this theory argue that humans took advantage of natural fractures, shaping them into terraces for coastal defense or ritual use. However, without definitive tool marks, this remains speculative. And this is the part that changes how we interpret everything. Deep seismic profiling of the surrounding seabed has just revealed that the sharp linear alignments of the platform run parallel to major regional tectonic fault vectors. This crucial alignment strongly supports the geological theory, indicating that the Earth's crust supplied the precise directional forces required to crack the stone at 90-degree angles. Yet, even the most rigorous geological models struggle to explain how natural wave erosion could cleanly hollow out the step-like recesses without collapsing the overhanging structures. Natural seismic pressure regularly mimics human engineering to a degree that completely fools the naked eye, but this site pushes that natural capacity to its absolute limit. As the edge of the stone platform drops off into the deeper abyss, the boundary between natural forces and lost history becomes dangerously thin. The 12,000-year-old structure remains one of the ocean's most compelling mysteries. It stands either as an unparalleled masterpiece of natural tectonic jointing or as a silent ghost site of prehistory that challenges our understanding of human capability before the oceans rose. You would expect modern technology to easily categorize a feature at 30 meters deep, but the data proves that nature can be just as precise and just as deceptive as any ancient architect. Every expedition to this submerged shelf brings us closer to understanding the structural limits of our planet's crust, proving that the line between geology and archaeology is still being written on the seafloor. This is the part that changes how we view the deep ocean entirely. The answers we seek may not lie on this shallow sandstone shelf, but further down, where the stone platforms plunge directly into the dark, unexplored spaces of the adjacent deep ocean trench. New sonar anomalies are already appearing on our deep-sea arrays at depths that human divers cannot reach. Initial acoustic data shows a series of even larger, parallel reflections rising directly out of the abyssal plain, miles beneath the surface. These deep-sea structures are currently reflecting our sonar pulses with an intensity that suggests an entirely different material composition, threatening to break our current generation of acoustic sensors. Next time, we turn our high-resolution sonar arrays away from the shallow coastlines and head out into the true abyss, where something massive is waiting to disrupt everything we know about the ocean floor.